So we are two developer advocates for Viam. We also have our other coworker, Ariel, here. And we're going to be going through a story of exploring data from end to end. So from collecting, querying, to analyzing it through visuals and other sort of tools. And it's been quite the journey for us over the past month or so of really digging into these tools and seeing what's possible and really trying to figure out what do people need when they start to explore sensor data and what it looks like to bring all that tabular data together, bring it from physical machines, and then actually get some use out of it.
Yeah. How did you get inspired for this project? Like, was there a real life need? Like, is it an example project that you wanted to build using sensor data?
Yeah, so I live in an old house with some older appliances. And so my washer and dryer are not like old, but old enough that they're not working 100%. And so as the person who does most of the laundry in the house, because I work in the basement and that's where the laundry machine is, and that's just my responsibility now, the washer would occasionally just stop working in the middle of a cycle and a load. And so that got very annoying. I'm like, there's got to be some way to figure out what's happening without having to go buy a whole new washer.
Yeah.
And so, first thing is to observe the problem and start to get some data around it before just willy-nilly trying to open up the machine, especially for a washer and dryer. I don't want to break it myself. I want to figure out what's going wrong and then try to find a solution. And so I just started by looking at what sort of sensors I could put on the device because I wasn't getting any data out of it itself. It's a dumb machine. So I added a couple smarts to it. And I have some spare Raspberry Pis, some spare sensors. And so I thought I'd add a little Viam on top and see what happens.
That's super cool. Can we see it?
Sure. So let's take a look. Your screen. What will help with here? Awesome. Thank you. So first of all, we're going to be using Viam's data management for basically everything we're doing today. And so starting off, this is what I ended up deploying to production. Yeah, so I have a Raspberry Pi in a case plugged into the wall right next to the light switch, and I have a little movement sensor there. That movement sensor contains accelerometer, a gyroscope, as well as temperature sensor actually on top of it. So it's giving me a lot of data about what's going on top of the machine. And I actually ended up putting the Pi itself on top of something else so that it didn't get disrupted by the actual movement. Because movement's not really great for electronics, we're finding out. Yeah. And so for this, I went and set up, a machine inside of Viam. I have my smart laundry location. I have my laundry monitor machine. And, I just grabbed a movement sensor component, and set up the I2C setup for, it's going to be using the first I2C bus on the Raspberry Pi. And then I started to configure the data capture. And so I can set up just general all readings for this, but I get some choices. So in case I want to not gather everything all at once, but I only care about maybe just the gyroscope data, which is angular velocity, or maybe I only care about the accelerometer data for linear acceleration. Funny enough, since this is a temperature sensor as well, I'd actually have to configure a different component in order to get that temperature sensor data showing in control, but it's still being gathered when I get all readings. So that's why I kind of just grabbed everything at once, just see like what's going on, and then I can maybe filter down from there if I get more specific data that I care about actually from that.
That's super cool. Does the data capture work for other types of sensors as well?
Yes, actually. So we have, for many of our components, there are equivalent data capture settings for them. So including stuff like a board. So if I were to set up a fake board, kind of getting these fake components set up is a really good way to just start testing to see what type of data come out of it without having physical hardware. So if I set up like a fake board, I could add a data capture method, and I could get access to GPIOs, which can be any sort of digital data that I want to get back and forth, or even analog data if I have a proper like analog pin or some sort of digital analog converter on board. And so that can give me some like more finite or variable data to come back from that. Other ones that we have access to, let's remove that one. Let's see, we can get, actually ARM data is very interesting. You could, if you have a robotic arm, like we have our claw machine inside the office, we can get data capture for the different joint positions and positions and what they're doing at all different times. This could tell us some good insights into like, all right, when it hits a collision, what's going on at that point in time, or how quickly are they moving at a certain frequency.
And I would assume you can do something similar for the camera and then actually start getting images.
Right. Yeah. So camera is one of our most popular ways to gather data, actually. And so for a camera, we have our ability to get point clouds, even if you have like a 3D camera, be able to read images and get images at any sort of frequency, and be able to be a bit more variable with that. So, exploring, for the most part, any sort of component you get will most likely have an equivalent data capture as part of it. That's just part of observing the machines over time. So you can see we have our grippers and movement sensors, power sensors, generic sensors, and even various input controllers as well. So, but to get captured data, you can start capturing data, right away, and it'll just save onto the machine. If you want to actually start syncing your data out, you need a data manager to go with it. And so you can set up your capturing. By default, it stores into a certain directory on the machine. You can start to add tags if you want to be able to have for different parts and different sensors, have different tags to go with them. And then syncing is also optional to turn on and off depending on when you want to do it. So there's capturing, there's syncing, and there's even capturing at each component level, because you could set up the same data manager for multiple components and then toggle on and off as you see over time, like, oh, I actually don't need this data anymore. And so I can have a bit more finite control over that. And even syncing, you can start to say like, all right, I want to get this data every so often. Maybe I would care about syncing that data back to VM data management maybe every night. I don't necessarily need to be constantly like uploading stuff. What's really great about this, even with Cloud Sync, it's not dependent on the cloud to always be online. So if my internet goes out occasionally, as a lot of residential internets do, I'm not worried about losing that data, because again, it stays on the device, and as soon as the internet is stable again, then VM will kick off another data sync process. And part of that process will be, okay, as soon as that data is confirmed in the cloud, then it actually be removed from that cache on the device, and only then will it be removed. And then VM will keep storing that until it's full up to a certain point, and start giving warnings about when it's full too.
Cool, that's awesome.
All of this again is part of our documentation. You can find out all sorts of things in terms of like how to add your data management services and all those sort of things that I walked through. The other parts you can extend with modules, especially, is the ability to do more conditional syncing of that data. So one of our employees here, Naomi, created a sort of cron job, which means you could trigger it at certain times of day rather than setting a arbitrary frequency at that point. So like I said, if I only wanted to just sync at 11 o'clock at night, I could use our sync at time module here to say, okay, at midnight, give me the latest data from the last day, or at 5 p.m. or whatever I really care about, doing all that and syncing it, rather than always constantly be pinging the cloud for that. Another way to be a bit smarter about the data that I'm capturing is what we have are called filtered modules or data filters. One example was talking about cameras. You could say, I only care about images of certain objects or people that I want to sync back. And so you could use one of our vision services combined with a filtered camera in order to say, okay, I've trained a model before, or maybe I'm using a generic model from the internet, and I want to say capture all images of a certain animal, and then that's what I'm going to use to train maybe a specialized thing or analyze from my data. Same goes with sensors. You could have a filtered module that takes in sensor data, and you can set certain thresholds, or have it be a bit smarter and train your own machine learning model that looks through that and says, all right, this is significantly different. I'm going to store that data. So it gives you control over not just having too much noise in your data set, but also maybe potentially saving you on some cost at the same time.
So you can basically have a trigger point. If it's over 100, then it means that something is wrong with my cycle, and then it only syncs that anomaly.
Exactly.
That's awesome.
So you can just,
Cool.
once you have enough, you can start to see, okay, here's some of the patterns. I can fine tune what the data I'm pulling in and what data I actually care about. So once we have our data, we can see what's going on in real time. This is actually live and deployed to my house. So we're connecting over WebRTC to try to see what's going on, and then we can see as it's going on, no laundry is happening as far as I'm aware. And this is what the data looks like. There's still some fluctuation. So it's not just like no movement means that like it's not running, or even some movement means it's running. And the earth moves. So like this is also gathering that through just being on top of the machine as it's normally just sitting there. So were I home and running some laundry, we could see how this fluctuates, but we've already stored a bunch of this data. And so we can take a look, not only through this nice link to view captured data from my machine in total, I can actually go to my washer movements and view captured data specifically for this device and this component. And this will bring us up to our nice list. It's already pre-populated with the machine ID, our part ID, and a bunch of different filters to just show me the data I care about. And so we can look into the details here. We can see what location it's part of, when it got this data, as well as various tags if I were storing those, and then everything it got during that point in time that it stored and synced that data. And we can see that we have our linear acceleration for the accelerometer. We actually have our temperature data here stored as quite a long float, and then our angular velocity details as well.
And if you just click on the data tab on top, it will also come to the screen?
Yes. So if you go to the data tab here, we're going to see all sensor data collected underneath this organization. It's actually just still showing our last filters. So if I were just to remove that, we would see all data. This is the latest that's been stored still within this organization, but we can still create our own filters as well if we only cared about a certain time that I captured this data or anything like that. But now I have all of this. So now I want to figure out what exactly I have. So maybe Zal, you can help me out with figuring out like what is in all this data.
Cool. So here, what we can start talking about is how to query it. I think I can go back here to show. I'm also going to say hi to my coworker Ariel, because we're going to do this section together. And I'm going to teach her basically how to query this data that we captured. Here in the same tab on top, you see near all data, datasets, models, query. There's a section that allows us to do querying of this data. I also wrote a blog post. So if you go to our blog, there's going to be a step-by-step explanation of how to gather this data, how to query it with a bunch of examples. But I'm also going to just walk you through how to do that right now.
I have a question.
Yes.
So what is the benefit of querying data over just looking at all of the raw data in the data tab that we were just looking at?
Yeah. So one good thing about querying data is that it allows you to narrow down what you're looking for. So if you were specifically looking for, as you can see here, like a specific component name, you will be able to tag it here. And then when you run the query, you will only see that component. In our case, because we only have one component, this doesn't really change much, but there will be cases that your smart device has multiple components in it, and maybe you just want to see one of them. It also allows you to limit it to a certain number. So here you will see the top 5 queries, but it will give you a little bit more flexibility around maybe you want to see just the top 2. It also allows you to drop down all of these query items. So instead of seeing when is it requested, which robot it came from, the name, maybe you just want to get the readings and then the temperature Celsius, it will allow you to do that. So I will actually go through a step-by-step of how to do that.
I
So
also like the way this is organized too, because when you look at the data in the data page, readings returns an array with all of these different values, and seeing it separated by type of return is also really helpful.
Yeah. Here we have two different query modes in the app. One of them is SQL, one of them is MQL, and I'm just going to give the same example in both so you can see the comparison of how it will look in different query languages. In this one, we're selecting all of the readings from readings, and the component name is version moment, and we're limiting into just the top 5 readings. And as you can see, it pops up all of this information, and then in the data, you will see the actual data that we are looking for. And then if I scroll down, you will see 5 of these because it basically limited to the top 5. I'm also have an example of the MQL version of how this would look like. So it is selecting the component name version moment, and then it's getting all of the readings from that moment, and it's limiting it to the last 5. So as I go down, this will look very similar to the other one. It shows all the parameters, time requested, time received, all that jazz. If we want to make sure that we maybe don't see the tags, we don't see the part ID, maybe we just want to see the data, then we can, let me close these tabs because we don't need it. Ooh. I'm just going to show the MQL example. You can actually add a phrase to like narrow it down. So in this one, you see the data, readings, temperature Celsius, which corresponds to this tab. So it goes to the data first, it goes to the readings, and then it only selects the temperature Celsius.
Right.
The limit is still 5, so if I scroll down, you will see the last 5 readings, but it will make it visually a lot less cluttered the more you add, like the more you narrow down your query.
Yeah.
You can add, like, again, organization ID, depends on your organization. You might have multiple smart machines in there that's gathering different types of data. So the more you add these tags, the more visually clear it will be for you.
Yeah, it definitely makes more sense, especially when you have a large database with a ton of information. This is just, I guess, a programmatic way to look through everything and apply all of these tags without, like a graphic user interface or something.
We also have ways of querying it from the Python SDK. So if you want to programmatically query it, that's also possible. You can also use like the Viam CLI to query it, but here it's an example of how to do it through the app.
Nice. Yeah, this makes a lot of sense for sure. I can think of another use case for checking your data this way. So I really like data visualization, and I think that, especially when you have loads of data here, I mean, how much do we want to approximate? How many pieces of data do we have in this data set?
10,000?
More.
40, I think.
Yeah, 40,000, right? So you have 40,000 pieces of data, and you filter to 5, 10, 100 with these SQL or MQL queries. But what do you actually like? What can you take away from all of this data other than seeing the numbers and understanding like where they belong in the database? So there are a bunch of third-party tools that you can use Viam and these third-party tools to visualize your data while using SQL or MQL queries. So you can see all of your data at a glance, so you can make actionable insights or predictions or anomaly detection outside of just understanding these numerical ranges and saying, okay, well, 19 is sort of my baseline, which means, we haven't started laundry. Okay, it spiked to 27. You want to be able to visualize that and see it so that, say if you're scaling this to 100 laundry machines in your apartment complex, right? How do you know when each one needs to get serviced or whatnot? So
what type of tools can you use to visualize?
So with Viam's open source nature, you can integrate it into many different products, specifically ones that utilize MongoDB Atlas integrations. So the ones that come to mind off the top of my head is if you are a data visualization nerd or a data scientist and you really like to look at large pieces of data in really like beautiful ways, I recommend Tableau. I actually wrote a really nice tutorial, a step-by-step guide on how to visualize sensor data in Tableau. You can create interactive dashboards, and you can do analysis on your different types of data These are examples of time series plots. So we can kind of see when things are spiking. You can build, heat maps. This is a step-by-step guide. And as you can see in this GIF here, when you import all of your data with a live database connection, you can be collecting data on this sensor on your machine, and it'll update it in real time, near real time. But this looks like a mess, right? This is like you don't know what to do with all this data, and this looks really similar to our data page as well. You can then start pulling out these data sources, and you can organize them into different filters and then put them into different plots. So you can see I just pulled out, the angular velocity and plotted that over time, and you can see how much this washer shakes. And this is a very zoomed in version, of course, but you can actually see and visualize these spikes, and you can get a sense of how much this is actually shaking. And same idea with temperature or anything else that you collect. You can create heat maps of temperature or your velocities over time, so you can see when things are moving in all the directions the most. And this is just a part of what you can do with Tableau. I really encourage people to check out this product, #not sponsored, but really, really powerful tool for data visualization. Another one that we have available, I just opened it, is Grafana. We also have a very nice tutorial on how to utilize Grafana, but Grafana is different because you will be using SQL or MQL queries to view this data, whereas Tableau, you were using a live database connection. So it's really similar as pulling out a CSV file, and you just have that raw data dump. With the next tool I'm going to show y'all, we will be just doing the exact kind of querying and the exact kind of scoping down on your information that Hazal showed. So let's go to our visualizing data portion of our stream. And welcome back, Nick.
I love visualizations. So
Yeah.
I'm excited for this part.
Yeah, so this is really cool too because you've collected so much data on your on your washing machine, right? But what do you do with all those numbers, right? So boom, here is a beautiful interactive dashboard where you can see all of the different values that your sensor returns. So as we said earlier, it's collecting angular velocity in 3 directions, linear acceleration in 3 directions, and then you have your temperature, right? And you want to look at these at a glance. And these dashboards are really great too because they're interactive. You can detect, here's a spike here. And if we want to zoom in, we can actually view that number specifically on whatever graph we choose. And then we can see when no laundry comes, to life. I don't know. This would be really cool. Can you text your wife and turn on the laundry right now? So we can actually do this live? Yeah. No. Well, if we wanted to do that, we could, but we will not be doing that in the stream. I'm sorry, everyone. But let's zoom in on one of the charts. So here's all of the data at once, and then I have grouped them into different types just so it's easier to comprehend. But let's look at temperature here.
Look at all that variability.
Yeah. So question, are you doing different types of cycles? Are you drying them on low heat or high heat? Does that cause this variation?
I mean, I'm typically doing a warm load inside of the washing machine, and so, but I think when I'm running the dryer at the same time, it definitely kicks off a lot more heat within the room.
Yeah.
Plus, we've had some spikes in the actual outside temperature that's affecting how warm it is in my basement.
Or your ambient temperature, your AC, central air.
Yeah.
So
central air.
Oh.
Yeah. I don't live in that ritzy neighborhood.
Well, I don't know. You have a house. So. But with that being said, right, you do see more variability in temperature, but I would say that the velocities and the accelerations are pretty, I would say consistent. Is a good word.
Yeah.
And
you see a couple of drops in there, which would be hard to see. Or just looking
maybe you had something
table,
right.
Yeah, it could have been a big sheet or something, or I often have to wash some of my son's toys, which maybe cause a little bit of a ruckus.
Yeah, and if you're looking, I don't remember which page it's on, but if you're back at this page, right? And you're scrolling and you're looking at these one by one, how are you going to pull these assumptions out unless you are visualizing data? So let's take a closer look at one of these tables, and I will show you that this can be done in real time. So because we were talking, maybe I'll scale these so they're easier to view. Bye-bye. So you can write queries. I'm choosing to do MQL because I use a MongoDB database connection.
Right.
This is like a plugin that already exists in Grafana, very easy to set up.
And that's because the data itself is stored in a MongoDB Atlas.
Yes,
Okay.
a MongoDB Atlas instance that is read-only.
Got it.
So you can't like alter the data in your databases. You can only collect them and visualize them or do some cool programmatic stuff with them.
Nice.
So the syntax is like nearly identical to the queries that we showed earlier in our app. But, we just like changed the pipeline slightly because we wanted to understand like where it's coming from. And this syntax belongs to Grafana. But the point is this is exactly the same. I scaled it to a much higher number so we can get a lot more. But if we brought it down to 5, I mean, maybe that's not a good example, maybe like 100, right? We can run this query live and our graph will change in real time. So all right, well, it's probably not enough, but because there's a lot.
Right, we're looking over days right now, right?
Yeah.
Not necessarily on like 5 items in there. If I was storing it at every half second or even every second, you're not going to see a lot from that. You have to zoom really far in, right?
Yeah, and you saw this error popped up, and I was able to fix it within seconds. So the querying is very fast as well. So you may ask, like, well, I see I'm only filtering to the sensor itself. Why am I only seeing one data point? Well, with this, you can actually filter. So instead of writing the specific, project this value in MQL, you can do that. But I chose a more broad approach and applied it to all of the tables in my dashboard. And then you can create these overrides where you can choose which pieces of data. And these are all the things that you would see when you create that big general query that we saw earlier, that big, nice piece of organized data. And you can pull these out one by one and choose which ones you want to view or hide. So that's pretty cool. And another thing that you can do with Grafana, which is pretty interesting, and maybe this will appeal to your project, you can create alerts for different ranges of information.
Oh, yeah.
So, maybe it's a safety hazard, maybe not maybe, definitely a safety hazard. If your washing machine goes over 100 degrees Celsius, that's way too high.
Oh, yeah.
But I was thinking Fahrenheit, but whatever the equivalent, help me, what's the number?
50 degrees Celsius.
Yeah, 50 degrees Celsius, like not a great number. But say, like, what if our data spiked that high? What can we do to tell us that that's happening? Well, you could write a script to do that, or you can utilize this third-party tool or others to do like text message monitoring, email monitoring, and say, okay, well, this just spiked here. Send Nick a text, and Nick goes down to his basement with a fire extinguisher, and all is well in the world, right? Well, think about this at a larger scale. If you have like a bunch of machines in a warehouse, or you're an apartment complex with like 20 machines in the basement, right? You want to make sure that you're getting this data ASAP and you're getting these notifications as soon as possible so you can actually fix these problems, or maybe like your angular velocity is going crazy. That means like maybe one of the axes on your dryer rotator thing, I don't know what they're called,
the drum.
The drum.
Yes.
Thank you. Scientific term, drum, is out of whack and you want to fix it right away. So it's definitely really cool how with Viam's open source nature, you can integrate different products or even write your own solutions for many, many different use cases.
This is actually really awesome because I'm running Grafana already within my home to monitor the state of my homework, which is a bunch of computers I just have connected for running different types of experiments.
Right.
So I can also pull in data from Viam just within that existing instance that I have, and store even more and visualize a lot of it.
Yeah.
But I have been getting more into data science and trying to explore machine learning, and a really popular tool I've seen is Jupyter Notebook. So how can I integrate Jupyter Notebooks with this sort of data? Can I analyze and visualize within that environment?
Oh yeah, absolutely. So you can access all of your data with the data client API. And there are a couple different ways to do it. You can do it using SQL or MQL programmatically, or you could also, as you can see, tabular data by SQL, MQL, or you can do them with like the different binary,
values and filters and everything.
Filters as well. And you can, I implore you to check out our documentation because there's a lot of different things you can do with it. And then you can use different libraries to integrate and create visualizations easier. So
we take a look at our Jupyter Notebook environment that we have.
Yeah, let's do it.
So running this notebook on just on my local machine, it's not running in the cloud or anything, and there are those Jupyter Notebook cloud environments. I know there's Google Colab, which will give you access to like a GPU instance or even just a CPU. But we have a Python SDK, so it looks like we can just install that within our environment and start to use that same sort of code example that you were showing me before to grab our API keys. So one important thing is like this, the output of this can be stored in GitHub as a project, and not to share API keys and expose it publicly. So I'm just using a .m file in my local project in order to get my API keys. And we're getting our Viam client from that. And that's going to give us, rather than our robot client, which gets access directly to the robots, which I could do to start getting some data in real time and visualize it here. But instead I want to grab a bunch of data at once from that central data management system.
Right.
So I can get my Viam client, get the data clients, and then here's one of those APIs we were talking about before. So a filter is another sort of structured data format that we can use rather than MQL or SQL.
Because they're all filters at the end of the day.
Exactly, yeah. So this will be much more familiar to that data view that we had before, where we have a bunch of filters on the side. So we can see, here's a location, a machine name, machine ID, and a similar set of stuff set up here. We have a component name, a robot ID that we can use to filter down the data we want. And we can loop over, in this way I'm just paginating through the return responses from our tabular data by filter, passing our filter, and then when we get to the end of what the last thing, this is how we're going to paginate by the last ID that we had in that return value, rather than actual pages. And so if there's no tabular data, maybe I don't even have over 2,000. I know we have more than 2,000, but in this case, I'm only getting up to 2,000 of them.
Okay.
And then we can actually, the nice thing about our...
Oh, this looks familiar.
Yeah, look at that. We have our tabular data, and it looks a lot like we were getting back before. And we can see our washer movements, part ID, and then that time requested, and even some of our overall data within there.
Yeah.
So our readings we can see here.
Cool. So once you have all that juicy data in your code, what's next?
Yeah. So we have Matplotlib is a very popular visualization and graphing and plotting library for Python. And so we're going to import that as plot, or PLT is very often the shorthand, an alias that people will create for it. And we also have pandas. Pandas being a very popular data framing library, which allows us to take multi-dimensional arrays, which something like our linear acceleration, which has 3 different directions, right? And we have our angular velocity, which is 3 different. So we have maybe 3-dimensional arrays that we can work with and doing math over that. Yes, exactly. And so we're going to create a data frame from our sensor data.
Okay.
Just pass it straight in. I'm not doing anything else to it. And then we can see it now in a nice, clean-looking table. Like
Which looks very familiar.
Very familiar as well. And so now we're seeing the same sort of things in this open source tool. We can see all sorts of ways that we're shorthanding it in the VM app, but also if you want to use your favorite tool, you get the same sort of output. We can see our all of our data here. We have our time requested, time received, and then we can start to even filter down from there using the pandas library and start to plot out our, like you were showing off with Grafana, but now just using maybe a more familiar tool people who work with in Python and want to do it more programmatically.
Yeah, or if you want it to be more tailored to your specific.
Yes, exactly. Use case. And so
look
now
at that. Beautiful.
I have a scatter plot rather than maybe a line graph that we were showing. And like the line graph might be the more obvious one because it actually is going over time rather than being scattered across like the same values and trying to show correlation between them, but we can still see the same sort of patterns we were seeing before.
Right.
In terms of like,
I mean,
this
they
interesting
look
spike there.
they look the same right here.
Look at that.
Yeah. So that would be angular velocity. So this is probably one of these chunks right here
Mhm.
that we're viewing up
And
close.
in this case, I'm only showing, you can see the finite amount of time that we're going over here.
Mhm.
So it's not even over multiple days. This is just, again, that one chunk of time. It looks like we're going over, it looks like 10, 20, 30. So, probably a couple hours right there.
So like a cycle, probably.
Yeah.
Nice.
And then so that's going over data, reading through the Python API, but we can also analyze data that we've exported. So maybe I want to get all of that data, and I don't necessarily need to iterate through 40,000 rows coming back from the Python API.
Mhm.
I can use the CLI to export it as what do we call it? It's a JSON lines file, but it's NJSON. And I used a tool called DuckDB to turn that into a CSV.
Nice.
And so I can,
Historical data.
yeah, all this data is now just a CSV, and we can take a look using the head method off of Pandas. I'm reading it again with Pandas to take a look at what the top 5 rows look like.
Mhm.
And again, looking very familiar, but I've now split it up more into specific angular velocity, linear acceleration, and temperature rows.
Right.
And allows us to take in all that data, create a bunch of plots out of it, and then now we get, like we were seeing before, we got accelerometer over X, and this is all of our historical data at once with no limits. So this is all the data I've gathered so far, and we can see these clear indications like when something's running, these interesting spikes. And if I had been paying attention while these things were happening, maybe I would have noticed that maybe that's exactly when something went wrong.
Right.
And I start to identify those spikes as ways to, once I start reading this in real time using our Python SDK on the device, I can say, okay, well, maybe I can start alerting from there versus in Grafana and get it maybe even closer to like as soon as that happens. And we can see again that familiar temperature, this anomaly here, like I don't know what happened there. Maybe something went wrong with the temperature sensor at that point, because I know it didn't go ice cold immediately within there.
Do you think maybe like an internet outage would cause that, or
not necessarily internet outage? Because again, if the internet goes out, then it's still going to be on the device. So it comes from the hardware, it's going to be stored. So maybe something where how it's stored differently, or again, hardware is fallible. Yeah. And so like the sensor itself could have had just a weird blip trying to transmit that.
Or
again, stuff shaking can also happen, stuff with wires. Yeah.
Or your basement got really cold because you have a ghost.
Yeah. I mean, the house is over 100 years old, so I wouldn't blame if there's like a ghost wandering around there somewhere.
No robots.
Yeah.
But technology prevails.
Yes. And it's great to see all these at once. We have all these different tools we can use. We're not stuck on one or another, or even like isolated to a proprietary area. We can take this data, it's ours to use, and go off.
Yeah, go off. Love that.
Yeah. I don't know if we have any questions in the chat right now. This has been a lot of fun over the last couple of months, really, that we've been kind of exploring this together.
Yeah.
Is there anything you've been inspired to maybe start to track using various sensors, even with images and things like that?
Yeah, so it's been really cool watching the data portion of our product evolve. And I think it's really powerful that we can export and do visualizations or real like inferencing on data, because I think that's where like the real interesting juice is, right? Collecting is also very cool, but what can you do with that data? How can you, use this data to influence people to buy more robots, or, your product that you built, or how do you fix things, et cetera? And I've had a lot of fun playing with these different visualization tools, creating content around them, so other folks can also go off and do their own visualizations for maintenance, monitoring, whatnot. So that's been really fun. It's been really, really hot in New York City recently. And I have a small garden on my deck, or should I say had, because I swear like the sun's moving differently recently, because I'm getting more sun on my deck more than I have in the last few years, or that's what it feels like. And I keep burning all my flowers. I wake up in the morning every day and I water them, and I come home and they're just crispy. So I've been buying annuals so that,
if they die, they die, and I don't feel too bad about getting rid of them. I would love to create a system where maybe it's like some, what is it, like hydroponic, aquaponic system, where I'm using, temperature sensors or moisture level sensors, and I can get a text message in the middle of the day, and it's like, your plants are thirsty, fix them, because I feel like I'm spending a lot of money trying to buy more flowers because I love the way they look, but they're just like so hard to maintain. Or maybe it's just me, I don't know. But I feel like there's got to be some automation or something I can do with the VM platform, some interesting low-cost hardware, and these free and or open source tools that, integrate nicely in our product. So
yeah, I mean, plants always end up at my home as well. And it's good to have something to keep track of them.
Mm-hmm.
And yeah, you're right. The temperature keeps fluctuating, and you want to not just always have the constant same amount of water giving to them. Right. Be able to use the environment, be able to be smarter about the way it's going to be automated.
Yeah, exactly.
Yeah.
Have you had any ideas? I know she's a little off screen right now, but we could let's reconvene.
Yeah. Here, can you pull your chair over? Or you can share a chair.
I was gonna just share.
Beautiful DevRel team.
Oh, there we go.
Oh, now you're the same height.
Yeah, there we go. I just have to go on my knees. That's all.
There we go.
I'm not sure if this would work, but I would love an audio tracker of like the levels of music that we have in our unit, because I live with 2 roommates, and like sometimes they make a lot of noise in the middle of the night. So maybe having like a graph so that I can show them the next day, like, hey, this is the type of sound.
The data says that you need to shut your mouth.
Exactly. So that would be or it's like a buzzer that like buzzes in their room and be like,
like a nice
quiet.
reminder.
After a certain hour. Yeah, so that would be a really cool project that will help my life a little bit.
Yeah, or if you have like a really noisy neighbor, you can use the data and be like, I heard you. I like
It's been a lot of fun. I hope that you all can join us, in Discord, and tell us about some of your ideas about what you'd like to build, what sort of data you'd like to analyze, maybe some modules that are missing to allow you to capture more data. Because if you build a module that uses any of our sensor APIs or any of those component APIs that we showed you before, you get access to data capture instantly. So you find something unique online, you're like, oh, this would be really interesting. We can make that happen. You can make that happen by building it yourself.
I see.
But yeah, thanks everyone for joining us today. Again, this has just been a lot of fun. We're really happy to share with you. We hope to see you all next time.
Yeah, and I hope you see data as beautiful as we all do in so many different ways.